All right, let's go. Class.
Yes.
All right, come on, you guys. This is my favorite class now. So let me hear it. Let me hear it. Class.
Yes.
Woo, man, that's good. Makes me excited about being here that you guys actually will do me the favor of pretending like you like this. So, all right. So what page are we on in the notebook?
37.
37. 30. There we go. All right, Euler. So this is actually, here in America, we refer to it as Euler, but I think he's like French or something like that. He's like from 1700 something. He's a mathematician and physicist that come up with all kinds of, I don't know. So do you discover math or do you invent math?
You discover.
Because the math is always there.
Yeah.
There's
always one right answer.
Yeah, but the math has always been there. You just found the formula to get there.
Mm-hmm.
Okay, good. All right. So they also refer to it as Eulers. So back there, because I don't know, they're a bunch of weirdos. I don't know, eating croissants and stuff. Anyway, so Euler path and Euler circuits. Blah blah blah. Come on. There we go. All right. A path is Euler path is a path that travels through every edge of a graph once and only once. Each edge must be traveled and no edge can be retraced. So let's take a look. So a path, I would start here and we go through and number these as you go. So please, okay, you could either number it or you could write it letter by letter. So if we're doing it letter by letter, I would say we're going A. I'm starting at A, right? The next one would be B. And the next letter I would write is
C.
E. E. Because it's number 2 here, right?
Oh, I don't like that.
Me neither.
Oh, hey, that's why I'm going over it. And so the next one is going to be, next letter I'd put is going to be F. Then D.
Oh, I get it.
Then B.
B.
C. E. D. E.
There we go.
That's a lot like that.
So, but if you notice, okay, consecutive numbers used to trace the path with your pencil. So what you're doing is, what's that?
I was checking if Styles was in here.
Oh.
I'll look for Styles.
He has up there.
He's up there?
Yeah.
What room number?
21.
21?
I think so. He's up with Grill.
Okay, thank you.
All right. So if you think of this down here on the bottom, it says use consecutive numbers to trace the path with your pencil. So you start one place, don't pick up your pencil, and you just go all the way until you get to the end. So you can't go over any of the lines twice, and you end somewhere else. Bless you, I think. There we go. Euler circuit. Euler circuit is a circuit that travels through every edge of a graph once and only once. Like all circuits, Euler circuit must begin and end at the same vertex. So a circuit beginning and ending at the same point. Beginning and ending at the same point. Okay? Beginning and ending at the same point. A path takes you from here and you end up over there. But a circuit, you would come all the way back around. So, okay, same thing goes with this. Use consecutive numbers to trace the path with your pencil. So I'm going to start here. So this is the same pathway that we had, but it just added another at the end. So we went here. We starting in here. So then it went to E, F, D, B, C, E, D, G, A. So we ended at the same place that we started. So that made it a circuit. Pretty easy, right?
Yeah. What? Don't say that though.
Okay, so right here, following statements are true for connected graphs. If a graph has exactly 2 odd vertices, then it has at least one Euler path, no Euler circuit. So what does that mean?
You can only make
It doesn't connect again?
It doesn't connect again, right? But you will connect all the lines. All the lines will be traced over. Okay, all the lines will be traced over. But we won't come back to the beginning. That's if we have what? 2 odd vertices here. Exactly 2. Second one, if a graph has no odd vertices, all even vertices, it has at least one Euler circuit. At least one Euler circuit, which by definition is also a Euler path. So, think about this. Now here's one of those logical fallacies or logical arguments here. So, all thumbs are fingers, right? All thumbs are fingers, but not all fingers are thumbs.
Well,
All thumbs are fingers, right? But not all fingers are thumbs.
Right. I hear your point.
That's true.
this.
So, all circuits are path. All circuit is a path. So every circuit is a path. Because if it's a circuit, that means I've connected everything, right? I've connected everything, I've gone through everything once. But are all path circuits? No. Because to be a circuit, it's got to specifically end at the same place that I started. Okay, for a path, I just have to go from one way and connect them all. All right, so, I don't know. I like throwing that thumbs and fingers one out there just to mess with people. Anyway, so a Euler circuit can start and end at any vertex. 3, if a graph has more than 2 odd vertices, then it has no Euler path and no Euler circuit. That's important because that's like a test question right there. If you're actually paying attention, because this is on the test. You're going to have to do this on the test. So this thing that we do is called a test, where it's a big chunk of your grade on this test. So I don't know, should I emphasize the test a little bit more? Yes, it's on the test.
You should know this, that you should go over back to
Okay, guess what? It's on the? There we go. All right. Now, explain why the graph in the figure has at least one Euler path. Use trial. So, I got a nice big one right here. So let's go through and start numbering these. So, we look to see what is the degree at each vertex. So, starting at A, that is 2. B,
3,
is it 3 or 4?
4,
C, D, E. Now, I have to look back at what I had on that last slide over there. Last slide. Do I have odd vertices?
yes,
How many odd vertices do I have?
2,
2. I have exactly 2. So which one does that fit the criteria of?
Not a circuit.
Yes, path but not a circuit. Path but not a circuit. Okay? So because of this, I am saying that this is going to be a path. And it is circuit. Something like that. I don't know, I probably misspelled it, didn't I?
I don't know how to spell
I know, I can't either.
C-I-R-C-U-I-T.
C-I-R-C-I-T?
U-I-T. Yeah.
Okay, just a little I, it's not like,
Yeah, it was odd.
eh. There we go. All right, so we're going to start somewhere. Oh, let's start with an odd. Did it say where to start it?
Start at A.
Let's see. Each Euler path must start at one of the odd vertices and end at the other odd vertice.
Start at D.
All right, so we're starting at
D.
D.
Yeah.
There we go. All right, so,
B, E.
okay, so let's see. So I'm going to go through and you guys, let's write this down to make sure this works. So DB, because I didn't write it down last time, I had to like go back over it again. A, C, B. Just so you know, I really don't know what I'm doing, so I'm just attempting this. So it might be, let's go E, because that's the only way I have left. C. D. And, oh, look, it did work. Out to E. So I finished at the other one. Wow, that last E is horrible. Ah! Okay, now the D, E. There we go. So I wrote my numbers down, my letters down one by one so I can know the pathway that I took. Because if you go through and, like, a lot of your drawings aren't going to be very big. So if you try and put the numbers in there, it's going to make it difficult. So if you try and put the numbers, it gets difficult. So it looks like, see this one right here? On your paper, it probably is not very big at all, is it? No. And so it's kind of hard to actually write it in there, and especially if you do make a mistake by taking your phone out during class and playing with it while I'm doing a lesson, that would be a huge mistake. That's like vegan level, huge mistake.
Hey. Don't hate.
See what I did there? See what I did there? Come on. That was a good one. That's like,
I didn't get it.
huh? You didn't get it? Okay, you know, like a mistake, as in like, yeah, kind of like the double, like double meaning of it, right? So you missed out on a steak, but the compound word of mistake is you have a problem. But in a vegan, they don't eat steaks.
Yes.
Yeah, so they miss steak.
It's a good dad joke.
You have to explain it. It's not funny anymore.
It's even funnier after the explanation.
It kind of is.
I know, right? Just for my joy. Alrighty, so let's go ahead and bam. Alright, you guys remember this thing from the last set of notes?
Oh, yeah.
Yeah, what's the guy's name? Like Kronisberg? Cronenberg. Cronenberg.
There's no R.
It's German. You know, it's like there's always an angry sound in every
Literally
German word.
Really?
You know, seriously. Yeah. Oh man, like every word is like angry. Like potato. Come on. What's potato is a benign word. It's like Kauffelfall. Or like I know a German word for ambulance. Is Krankenwagen.
Oh.
Well, literally, it sounds like that.
It is. That's it. Everything sounds angry in German.
It really does. And then
Okay. Okay, so Fleury's algorithm, finding possible Euler paths, Euler circuits. Now, this is going to be key to doing a lot of these things, and it's going to save you time, effort, and headache. So, we're going to have to try and find the path that we're going to make. Euler's theorem indicates that the existence of a Euler path or Euler circuit, one can be found using this procedure. If a graph has exactly two odd vertices, choose one of the odd two vertices, starting point, and then if the graph has no odd vertices, choose at any vertices at the starting point. So, on the last one, we had two odds, didn't we? Say yes.
Yeah.
Two odds, so I started at one of them, and I ended at the other. So that works if I have two odds. Number two, number the edges as you trace through the graph according to the following rules. Okay, this right here, this sucks. Don't do this. Okay, don't do this because I want you to erase stuff on here and bridges and all this. It's a mess. It really is. Don't do it. Let's make life a whole lot easier. So what's the first thing I did when I did that previous problem?
You
On the
counted
first.
the edges.
Vertices, right? Got the degree, so let's do that first. Let's find the degree here. All right, so alphabetical order. A is
2,
2. B is
2,
C.
3,
4,
D.
3, 4.
E.
2,
F.
3,
4, 4.
Also, it's gonna, it's a circuit.
Okay, it should, right? So because why?
Because there's no odd numbers.
There's no odds. They are all
Even.
even. So according to the rules that we had, this one is going to have,
At least one circuit.
it has a circuit, right? It's going to have a circuit. So we're going to start wherever.
E, E,
I'm going to start at D just because. I don't know. For me, whenever I'm doing these, I like trying to start at the highest number and then work my way around. So if you usually start off in the middle, it actually makes life a whole lot easier. So notice the figure has at least one Euler circuit because the graph has no odd vertices. And so I'm going to start at D. So let's go through and someone write these down for me so I could actually put it up here in a second. All right, so I'm going to start D. I'm going to go DB. And from B, I only can go to one place, which is going to be F.
C,
Let's do E, because I could take care of E and not have to worry about E anymore, right? Because once I finish this, then I'm done. But I do have to come back to F, so I'm going to finish this one. Now I'm down to C.
F,
Now I'm going to go back to F.
Then come down to D.
Yep. Okay. I'm going to come down to D. And now
What?
N,
back to C, right?
Then
A.
D,
D.
There we go. So the process I did, I started off and I tried to work to eliminate some of these edges. I eliminated the vertex B, then I went through and eliminated the vertex E. By going through and just making sure those are taken care of, then I can go through and work on the rest. So let's go through. Now what was my letters for those people that are watching on YouTube right now?
D, E, F, E, C, F, E, C, A, B.
Ah, not B, it's D, right?
Yeah, it's D.
There we go. There we go. Oh, that's a B. There you go. All right, está muy fácil?
Demasiado fácil.
C, C. All right. Hopefully you guys actually are finding this kind of easy. It's just a puzzle. And here is, right here, different ways of actually trying to trace it out. I hate going through this. It's easier to just trial and error on these. Start with the highest. That's what I always do. Makes life easier. And they went through and they started at, where'd they start at? They started at A. So it really didn't matter where to start at, but you just have to go in a process to try and get rid of and eliminate some of these vertices. Make sense? Okay, good. All right, so guess what? That's it. Yes, make sure you guys all like, share, and subscribe. You hit that notification button and support my channel. 10% off merch store. Promo code
Early bird.
Early Bird. Early Bird. There we go. All right.